So today I'm jumping ahead. So if you're looking at the lecture slides say that we should be doing lists today. I'm just going to skip over lists for the time being and come back to it in a couple of lectures. And so instead we're going to talk about strings. Because we know what a string is, but we haven't really used the string header file to operate on strings. So strings in C are a bit odd, and it has to do with the fact that the language is old. Most of you know strings as being a sequence of characters, right? And so the characters look like things that you can print to the console. In fact, what's actually happening is that they're stored as integer values, and these numeric values are mapped to the characters they get printed. Now the thing is, there's many different encoding schemes, right? So there's many ways to map an integer to a printable character. The weird thing in C is that C doesn't say what the mapping ought to be. So in other words, it's up to the compiler to decide, or the compiler implementers to decide what mapping will be used. So if you click on that link there, you can see there's many types of character encodings. Right? ASCII and extended ASCII are quite old, but still very commonly used. Java uses UTF-16, and I'm not sure what Python officially uses. This thing, no, it's still working, okay. You can ask your operating, normally there's a way to find out what encoding is being used. On Linux you can use the command locale. Oops, sorry, on other operating systems you'll have to do something else to find out what your device is using. So for our purposes, C strings are just arrays of characters, right? So number one, they're always arrays, right? And we're only going to use array of char. But again, the language is odd because you don't have to use array of char to represent a C string, right? There's actually many different ways that you are allowed to represent a string, right? So char is the way we're going to do it. Way back in the day, it would be int. In more modern times, where we've realized that there's more than just the 26 letters of the English alphabet, right? There's now something called WCAR-T, so that's wide character type. So it's capable of, char is just 8-bit normally. WCAR-T is wider, so it can hold more, or it can represent more characters. Right? And then there are these other two types, char16 and char32, 16-bit char and 32-bit char. We're just going to assume char. Okay, so there's no separate string type in C, which again is also awkward, especially if you come from a more modern programming language. So instead, you're always working with arrays of characters, or pointers to arrays of characters, or pointers to characters. Right? If you look in the standard library, so the header file string.h has a bunch of functions that operate on strings. You'll see that there's multiple versions of every function. One of the versions operates on strings made up of chars. Another version will operate on strings made up of WCAR-T, so the wide character type, and then there may be other versions as well, depending on your compiler. Right, so we're always going to be looking at the ones that operate on char. And now because a string is just a C array, and there's no way to carry around the size of an array with you, strings need some way to indicate that the end of the string has occurred. So every string is said to be null terminated. Right? Now null terminated just means that the actual char whose numeric value is 0 marks the end of the string. Right? So the null character, if you write it as a character, is single quote and \0. Right? The value of that character is the integer value 0. Right? So don't confuse the two. So that thing there always is always there at the end of the string. If it's not there, then you don't have a proper C string, and the standard library functions are not guaranteed to work. The other strange thing is that you're allowed to have more than one of these characters in an array, right? So you can have an array where all of the values are 0, right? The first 0 in the array indicates the end of the string. Now, it's just an array, so there's nothing stopping you from making an array of car and not putting in the null terminator, right? And so if you do that, you can't safely use that as a C-style string, right? If you pass it to one of the standard library functions, there's a good chance that bad things will happen, because all the standard library functions, not all, many of the standard library functions are going to be looking for that character so that they can stop processing the string. Okay, so the size of a string is the size of its underlying array, right? The size of the array that holds the string. The length of the string is the number of characters before the first null terminator, right? So string length is just the number of characters in the string, not including the null terminator. String size is the size of the underlying array. Right, so here we've got an array called S, right? We've said its size is 16. Right? So the size of S is 16. The length of the string, though, that's in it, that it contains is 1, 2, 3. Right? So there's 3 characters, and then there's a null terminator. Right? So if you print its size, you'll get 16. And if you print its length, you'll get 3, right? Which we can do in the console. Okay. So this is size of. Right? Oh, wait, sorry. I probably edited the code last term, so hang on. Size. Oh, so it's size, sorry, it's size. Size here. There you go, so 16 and 3, right? If we move that null terminator around, right, so if I shift this, so let's just move it to here. Here, oh wait, Control Z, sorry. Comma 0, like that. Okay, so the size of that array is still 16, but the string length is going to be 1. So recompile, rerun. Sorry, wrong one. Run again. So now the length of the string is 1, right? Even though, even though there are other non-null characters in the string, right? So that first null terminator marks the end of that string, right? As far as most of the standard library string processing functions are concerned. Now you can do all sorts of weird things in C. So you can do that. So I can put in a second null terminator, right? Now S, the length of S is 1, right? Because it has 1 character before the null terminator. But the string that starts here, right? So the string starting at the 3rd element of S has length 2, and you can get that string, right? So that's one of the unusual parts of C, and the fact that C has pointers. Right, so you can make a string. You don't have to make it as or you don't have to declare the string as though it were an array. Right? Arrays and pointers are almost the same thing in C. So I can create a second string, or not create. I can have a second string S2, right? And it's going to start at there, right? At the 3rd character of the string S, right? Or you could do S plus 2. Right? Either way is fine. Right? So the string that starts at the 3rd character has length 2. Right? You can actually pass S2 to any one of the string functions, and it will process the rest of that string just fine. So we've seen string literals, right? A string literal is just a sequence of characters inside of double quotes. Right? If you create a string literal, the compiler adds an extra null terminator at the end of the literal for you. It does this even if your string has a null terminator in it. Right? So that's a bit strange too. So let me explain what I mean by that. So rather than creating an array, rather than using the array initialization syntax if you know what the characters are in your string, you can use double quotes, right? So here S is the string ABC, right? The size of the array is 4, right? 3 characters plus the null terminator, right? The compiler silently inserts it for you. The length of that string is 3, right? 3 characters, then the null terminator. If you insert a null terminator into the literal yourself, right, you end up with perhaps a strange result, right? So 1, 2, 3, 4, 5, 6, 7. So there's 7 characters in that string, right? So the size of S2 is at least 7, right? It turns out it's actually 8 because the compiler sticks in another null terminator at the end. So I think this is size of 2? Sorry, I forget what the name of the program is. Cat size, what's that one? No, size of 2. Okay, so that's the weird one, right? So there's ABC. So that's going to give you 3 for the, sorry, the size of that will be 4. Its length will be 3. This one's going to be strange. So let's see what happens when we run this. So let me just recompile it in case I've accidentally changed it. Okay, so the size of the first string is 4, right? Which makes sense, 3 characters plus the null terminator, right? The length of the first string is 3. The size of the second string is 11. Okay, so 1, 2, 3, that's 1 character, so that's 4. 5, 6, 7, 8, 9, 10, right? And then the compiler inserts an extra null terminator at the end to give you 11, right? The length of that string is still 3, right? So it's the length, it's the number of characters before the first null terminator, right? If you look at the string starting here, that will be 1, 2, 3, 4, 5, 6. The length of that string will be 6. I guess let me just edit that program to show you that you can in fact get the length of that second string. So 1, 2, 3. So if instead of I ask for the string length of S2 plus 1, so 1, 2, 3, 4, right? Plus 4. So that's going to start at the D. Right, now it tells you the length of that string is 6. Right? So the fact that you can use a pointer to point at the start of the string or the start at the sequence of characters, or sorry, at the starting character that you want in a sequence of characters means that you can encode lots of different strings into a single array if you wanted to. Right? Now be careful with size of, right? So I already warned you once about this when talking about arrays. Right, size of gives you the size of an array if the array was, if you're referencing the array via a statically allocated array variable. Right, so in other words, if you make a little function, you make an array, you declare a little local array, then you can ask for the size of that array inside that function. Right? If you have a dynamically allocated array though, that doesn't work. Right, so never ask for the size of a dynamically allocated array, because you end up with the size of the pointer, not the size of the array. Right. What's this one doing? Oh, so this one works. Right. So here we have a pointer, right, to the string literal ABC. So the size of that is going to be, oh right, size of S2. So that's a pointer now, right? You've declared S2 to be a pointer, so when you ask for the pointer size, that's 8. Right, on my computer anyway, right? So it doesn't actually give you, this one will tell you it's 4, 1, 2, 3, and then the null terminator is 4, right? So if you declare it as an array, if you take a pointer though to that string literal, then the compiler thinks that you're asking for the size of the pointer, so that's 8. Right. Okay, if you want to do stuff with strings, then you're going to call a function on the string. Alternatively, you can write your own functions to work on strings, or you can write code that uses the pointer or the array directly. right? But for the common string operations, you're going to use a string function that's created for you. Right? So you're going to want to use string.h for many string operations, right? And so there's a bunch of different functions in this header that are declared in this header file. It's worth quickly taking a look at them, right? Let me scroll. Here we go. Oh wait, these are standard lib string manipulation. Here we go. Right. So you can do things like copy a string, right, or concatenate two strings, or allocate and copy a string, but you can't do that until this year, not officially anyway. You can ask for the length of a string, right? You can compare two strings for their dictionary order, and so on and so on and so forth, right? So there's, these functions here are useful too. They manipulate memory directly, and we'll see how to use those in a later lecture. Okay, so string length is the function that you want to call if you want to know how many characters are in a string. Right? And so that returns the length of that string, assuming the string is null terminated. Right? So assuming that there actually is a 0 somewhere in that string. Right? The language says you get undefined behavior if that string is not null terminated. The language does not check if the string is null terminated, right? The assumption is you've given it an null terminated string. If you didn't, it's your problem, right? Strings are weird in C, right? Because they're just plain old arrays, there's no way to know, or there's no way for the compiler to know, how big is that string. So it has to compute the length of the string, right? And the way it does it is it looks at every character in the string until it finds the null terminator. So C strings are slow if you are always asking for the length of a string, right? In languages like Java and Python, the string classes will have a field that stores the length of the string, so you just look up the value of the field. In C, there's always a loop running to find out how many characters are in the string. Now, if you're, one of the most common errors in C is that you pass in some pointer of some kind, right? Like a pointer to a string, and the pointer that you pass in is pointing at a string, but there's no null. It's pointing at an array of car or a car, but there's no null terminator, right? And so it turns out a lot of C functions have this problem, right? They're looking for a special character to indicate the length of the array, but that character doesn't exist, right? And so when the function runs, it just keeps on going well past the end of the array until something unfortunate happens. Right? So you're going to see this problem a lot when you work in C. And so there's a bunch of functions in C that look the same as another function, right? So string length. Here there's another one that looks almost the same, but it's called string n length underscore s. Right? If you ever see that n inside of a function, it almost certainly means that this function takes in a second parameter, which is the number of, in this case, the number of characters at which, so the number of characters after which the function should stop looking, right? So in other words, string n length will determine the length of a string, right? But it will stop searching after a specified number of characters, right? So if you suspect your string, or if you know your string should be fewer than 10 characters long, right, you would pass in the 10 as a second parameter, and then the function will stop, right? Hopefully that prevents problems where you run past the end of an array. It's still up to the programmer, though, to pass in the right value of n. So if you pass in the wrong value of n, it's still going to go past the end of the array. Right. So how do you implement string length? Well, you're just going to write a loop. Right. So there's my pointer to a string. Right. It's not an array because, again, in C, you can't pass an array to a function, right? It always degrades to a pointer. So there's my pointer to a string, right? I want to count how many characters are in that string until I get to the null terminator, right? So that's going to be both my index and my count, right? So I'm going to start at index 0 of the string, right? I'm going to look at the value inside at string at index I. Right? If it's not the null terminator, right, then the length of the string goes up by 1. right? So I++. And then you look at the next character, and then so on and so on and so on and so forth, right? When you hit the null terminator, the while loop exits, and that is the correct length of the string, right? So you could certainly implement it this way, and this is probably the way most people, most new programmers to C would implement the function, and it's perfectly fine, right? Again, notice there's no error checking here, right? If you pass in a null pointer, something bad will happen, right? If your string doesn't have a null terminator in it, something bad will probably happen, right? Or might happen. Can you implement this another way? The answer is yes, you can implement this many, many different ways, right? So this way takes advantage of the fact that str is a pointer, but it's very strange if you look at this function and you don't really understand or really have a concrete understanding of what the operators are doing, right? So believe it or not, this is exactly the same as the previous slide, but it's doing it, it's doing the dereferencing in a very strange way, right? So there's my pointer, right? There's the post increment operator there, and there's a dereference operator there. And so when you see this expression, what you have to do is you have to say, well, what is the precedence of the operators in this particular situation, right? And so you go and look up the precedence, right? And you see that the post increment operators have the highest precedence of all operators in C, right? Well, they have equal, all of these have the same precedence, right? So it's the same as function call or array subscripting. Right. So in this particular expression, right, the plus plus is going to happen first. Right. After the plus plus has happened, there's your array, there's your pointer dereference operator, right? So it has precedence level 2. So what happens after plus plus, right? And at this point, you might say, well, that's a mistake, right? Plus plus when applied to a string, when applied to a pointer, moves the pointer one position to the right, right? So adds 1 to the pointer, right? And then it looks like you're going to dereference it, right? And so when you look at that for the first time, it looks like you just skipped over a character, right? You skipped over the first character, but that's not what happened, right? Because the plus plus operator is funny, right? So x plus plus means, right? Use the current value of x, right? And then increment the value of x. So str plus plus means use the current value of the pointer str, dereference it, right? So the first time this runs, it's going to look at the first character of the string, right? After you've done using the pointer, now add 1 to the pointer. So now move it 1 to the right, right? And so that is not uncommon to see if you look at code that's written by very experienced C programmers, right? It's hard to read, even for experienced C programmers, right? It requires the programmer to know in detail what these operators are actually doing and what their precedence is, et cetera, et cetera, et cetera, right? So that's correct. I don't recommend you use it I don't recommend you write that until you're very comfortable with the language, or if you're trying to impress an interviewer on a job interview or something like that, right? You can do this lots of different ways though, right? So you can use a little for loop. So here, I'm going to create a pointer s, right? I'm going to start s pointing at the first character of the string, right? The loop should run as long as the value that s points at, right, is true, right? Remember, this is a condition in a for statement, right? So that has to be some sort of Boolean expression. Boolean expression here, right? So what's star s? Star s is a char, right? A char is an integer value. So as far as the language is concerned, you can use that as a Boolean expression, right? As a Boolean value, right? If the character is 0, right, then that evaluates to false. So this loop stops running when it runs into the null terminator character, right? If the character is not 0, the loop runs, right? So this just advances the pointer s forwards into the string until it reaches the null terminator, right? So in a picture, you would have the following, right? So there's my array, str. Right, now remember, str points at the first element of the array. Right? Somewhere in the array there's a null terminator. Right? And so this loop is going to advance s until it reaches the null terminator. Right? How many characters are in the string? Well, I can subtract the 2 pointers. Right? So I can use pointer subtraction here or pointer arithmetic here to get the length. Right? Because remember, for 2 pointers into the same array, the difference is just the difference in the two indexes, right? So this is just the difference between index 0 and whatever that index is, which is the length of the string. And there are many, many other ways that you could come up with to implement this loop, right? But again, notice that in order to understand this function, you have to really understand what the pointer operations are, right? You have to understand what the dereferencing does. Right? You have to understand that when you dereference this, you're actually getting an integer value, and I can use that as a Boolean value. And then you have to understand what the pointer difference here does. Okay, string copy. This is from the quiz. Right? So string copy copies a string. Right? It copies the string that's pointed at by that pointer into the string pointed at by that pointer. Right? And you know from the quiz that that is supposed to be a null terminated string, right? If it's not, bad things happen, right? So you can think of that as being an array, and you can think of that as being an array, right? If the destination array is too small to fit the number of characters that are in the source array, that's a problem, right? The bad things will happen. Right? So the behavior is undefined if the destination array is not large enough to hold the characters from the source array, right? It turns out that if your strings overlap, that can also be a problem. And you might say, well, that's weird. How can 2 strings overlap, right? Because aren't they 2 separate arrays? The answer is no, right? Because, or not necessarily, because that's just a pointer and that's just a pointer, right? So you can try to copy a string into the same part of another string, right? You just have to pass in 2 different pointers. So, if that's your array, right, and that's S, right, so S points at the first character, or that's source, right, there's nothing from stopping you from creating another pointer, right, and asking string copy to copy the contents of source into the string starting at dest, right? It'll actually work if there's a null terminator sitting somewhere between source and dest, right? So that will arc fine. If the null terminator is over here somewhere, that's when the function might run into a problem, depending on how the function is implemented. Well, actually, it's always going to run into a problem, right? So may not work if the strings overlap, right? I think if either one of these is null, you'll also run into problems, right? The function doesn't really check anything for you, right? So there's generally no input validation in any of these functions. So how do you implement this? So, I mean, this is probably the way you implemented on the quiz, right? That's an array, just copy the elements from the source array into the destination array, right? So starting at index 0, right, as long as the character in the source array is not the null terminator, right, just copy that character into the destination, right? The only thing you have to remember, right, is that this loop stops when it sees the null terminator. So it never copies the null terminator into the destination, right? So you have to copy the last character you have to copy the null terminator into the source array, from the source array into the destination array, right? So you can do it this way by declaring I before the loop so that I can use it after the loop. right? Or you could write, but if you declare I inside the loop, you can figure out what is the length of the source array, of the source string, sorry, and then set the destination array element to the null terminator manually. Right? But that's one way to do it. Is this the only way to do it? Of course not. Right? You could do it this way as well. Right? So again, you can play this funny trick with the post increment operator and the pointer dereference operator. Right? Now, string copy, if you look at the, if you read the documentation carefully, it says it always returns a pointer to the destination string. Right? So in other words, it always returns whatever value you passed in for dest. Right? Here, I'm going to change the value of dest. So I have to remember what was the original value when we called the function. So that's why this variable is called save. Right? And now this trick here, what's happening here? Right? So dest plus plus and then dereference it, right? So use the current value of dest and dereference it, right? So that's going to be dest 0, in other words, when the loop first runs, right? And that's equal to source 0 when the loop first runs, right? After the assignment happens, move dest 1 position to the right and move source 1 position to the right, right? Second time the loop runs, right? Do the assignment again, right? Now, notice that this is very weird, right? Inside the, that's supposed to be a condition, right? While some condition is true, right? Run the loop, or run the loop body. But that there is an assignment expression, right? Something gets the value of something, right? So in C and in Java, actually, the value of an assignment expression is equal to the value that gets assigned into the variable on the left-hand side, right? So when does this loop stop running? When you assign 0 into the value of the left-hand side, right? Because while 0 is false, right? And so the loop stops running. So this loop stops running when it sees the null terminator in source, or when it assigns the null terminator in source to destination, right? So this one actually does the assignment of the null terminator and then stops. Okay, so you can ask the question, I mean, if strings are just arrays, why do I need an assignment operator, or why do I need string copy, right? And the answer is because you can't assign arrays in C. Right? So if I want to copy one string to another string, I can't just use plain old assignment. Right? So if I have a string S, right, it's big enough to hold the string that I want to copy. Sorry, I have a string S. It's not initialized to anything, so it's just an array of size 100. If I try to assign a string literal to that array, right, the language doesn't let you. Right? The compiler says that's an error. You can't assign to an array. So if you have an array and you want to copy a string into that array, that's when you use string copy, right? If you want a copy of the string, you can't make an array and then try to assign it the value of another array, right? That never works in C, right? What you can do, though, is you can copy the string into the array. All right, so I mentioned that if you ever see a function that has an n somewhere in the middle of it, that's almost always an indication that this function is going to take in a second, or in this case a third parameter, that indicates the number of things to do before it should stop. Right? So strn copy copies up to that many characters from the source into the destination array. Right? So copies at most count characters from that string into that string, right? Including the null terminator, as long as count is big enough, right? And so this function is safer than the other version of string copy in the sense that it's not necessarily relying on the null terminator in source to indicate the end of the function, to indicate that it should stop copying, right? It'll copy at most that many characters. Right? Okay, so it's still not that safe though, right? It's safer, but if count is bigger than the length of the source array, then you may run into a problem, right? Because if count is longer than the source array and the source array does not have the null terminator in it, then you end up with you could end up with a problem, right? It'll go past the end of the array and then possibly cause bad things to happen, right? It still doesn't check if the destination array is big enough because it can't, right? And so if the destination array is not big enough, again, you run into problems, right? It can't handle overlapping strings, but that kind of makes sense, right? And if either destination or source is not actually a pointer to a character array, you'll run into a problem. Lets you copy a substring of a string into dest. Oh yeah, you're right. So strncopy is the function that you would consider using if you want to copy a substring from one string into another string, right? So I want to copy part of a string into another string, right? Not necessarily the whole thing, right? So here's my string 0 through 9, right? Here's another array, t, and I would like to copy the 3, the 4, and the 5 from s into t, right? So string n copy in this case is the function that you want, right? So I want to copy into t, so that's my destination. Right? Now, where does the string start that I want to copy into t? Well, it starts at there, the fourth character of s. Right? So the fourth character of s, the pointer to that is just s plus 3. Right? Or the address of s square bracket 3, however you like to think about it. Right? How many characters do I want to copy? Well, I want to copy 3 characters. Right? So there's the 3. Right? Now, what you have to remember is that if you're only going to copy a substring, right, you're not copying the null terminator into t, right? And in this case, we need it because t doesn't have one yet, right? So we have to insert the null terminator manually in this case, right there, right? You don't always have to do that, right? So if t had some characters in it and it had a null terminator already, right, then you can just copy some characters from s into some characters of t, right, and not necessarily insert the null terminator, right, as long as t already has one somewhere. Right? But in this particular example, you must add the null terminator. If you don't, t is not a proper string. If you try to pass t to a string function, bad things will probably happen. You're probably missing Java and C and Python by now. Right? Now, strncopy is supposed to be, quote unquote, or looks like it's a safe version of string copy. Turns out it's not. Right? So there's actually, this website here is a repository of well-known bugs that cause security issues in software. And so strncopy is one of the functions that's flagged as being dangerous. Right? The problem is it doesn't guarantee that that the string is null terminated, right? It turns out it also does a bunch of unnecessary work, but that's because of the history of the function. It was never meant to do what most people use it for now, right? And so when you use it, you either have to be very careful that you're using it correctly, or you can consider one of the alternative functions that are listed there. Right? So just be careful when you use it. But that advice applies to all of the string functions. Right? All of the string functions are dangerous in the sense that they take in pointers, right? And they rely on the fact that strings are null terminated in order to do the work that they need to do. Okay, strcat concatenates 2 strings. Right? So it appends the string pointed at by src onto the end of the string pointed at by dest. Right? Now in this case, right, it needs to know where is the end of dest, right, in order to append to the end of it. So dest has to be null terminated. Right? Source has to be null terminated because the function needs to know when should it stop copying characters from source onto the end of dest. Right? If either dest or source is not null terminated, bad things happen. Right? Again, there's no error checking here. Right? The compiler can't help you because of the way the language works. strcat does guarantee that the destination string is null terminated as long as there's sufficient space to hold all the characters. Right. Okay, so here we go. So S is going to be my, I should have did this the other way, sorry. So S is going to be my destination string. Right, so it has 5 characters in it currently, but it has space for 10 in total. Right, 10 characters plus the null terminator, so its length is 11. Right. T has 5 characters in it, plus the null terminator, right? So I can safely copy T, or sorry, I can safely append T onto the end of S, right? So I can safely call stringcat, appending T to the end of S, right? So T stays as the string 5, 6, 7, 8, 9, null terminator. S becomes the string 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, null terminator. Right? So if you actually print out that string, it does in fact work correctly. Right? If you make that string shorter than 11, there's no guarantee that it works correctly anymore. Right? Because there isn't sufficient space in the array to hold all of the appended characters. There's also an strncat, right? So again, a version of stringcat that concatenates at most n characters, right? And just like strncopy, it gets a lot of criticism on the internet, right? So strncat is the same as strcat, except it depends at most count characters to the end of the destination string, right? There's a problem with this one, right? And the problem is that programmers are by nature lazy, right? And they don't read the documentation of the function. Right? And so when you read the documentation of the function, it tells you, right, count is the number of characters to, the maximum number of characters to append to the end of the destination string. Many programmers interpret count to be the total number of characters in the destination string, right? And that's not what it is, right? It's the number of characters to add to the destination string. Right? If you interpret it as the total length of the string, then everything falls apart. Okay, so here's another example, right? So S is going to be my destination, right? So I have space for 10 characters in total, right? T is the string that has 10 characters in it. So I'm going to call strncat. Right? I'm going to concatenate T, the characters of T onto the end of S. Now that 10 is the number of characters to concatenate. Right? It's not the maximum number of characters in the destination string. Right? And so what happens? Well, it takes the 5, the 6, the 7, the 8, the 9, the 0, 1, 2, 3, 4, and tries to add it to the end of S. Right? What happens then? Well, there's more characters added to S, then there's space in the array S, right? And weird things happen. So let's see what happens. So do I have it here? Where is it? It should be in strings. Find dot minus name, str. And start. Oh, I guess I don't have it here. Is it, oh wait, it's cat, there it is. Okay, so concat n. There we go. Okay, so notice what happened here. So there's my string t, right? 5, 6, 7, 8, 9, 10, 1, 2, 3, 4. Right? And there's my string s, 0, 1, 2, 3, 4. So that concatenates all the characters of t onto the end of s. Right? And notice what happened. Right? S does in fact appear to be all the characters of t concatenated onto the end of s. Right? And so it looks like it worked. Right? And if you ran your program and you only used s, right, you would think that everything was just fine. Right? It's not until you look at what happened to t that you realize something bad has happened. Right? Somehow the function has changed your string t into the string 1, 2, 3, 4, which is strange. Right? And so what's happened is when string cat ran, right, there's s, right? It then took all of these characters and stuck it onto the end of s, right? And so when you do that, when it runs past the end of s, it writes the remaining characters into t. So here it's written the characters 1, 2, 3, 4, followed by the null terminator into t, right? And that's why when you print t, it looks like it's 1, 2, 3, 4, right? So in this case, str and cat has not only concatenated characters onto s, it's actually changed the source string t, right? Which is not what it was supposed to do. Right? So again, the fact that C has no index bounds checking or no error checking in general whatsoever, for the most part, right, often leads to very difficult to find bugs. Right? Notice that the program ran. It compiles cleanly, it runs cleanly. You don't get an indication that something unusual has happened, right? And so it's up to the programmer to be extremely cautious about what they're doing when they're calling functions like str and cat, right? So you have to be very aware of what you're doing when in the language, right? The language doesn't really have any safety features in it, so you have to be very careful when you're using it. All right, so I'm going to end things there, and we'll, I think, finish the lecture in the next class. Right? There's still a bit more to talk about with strings. All right, so have a good weekend, everybody.